Day 17 of me solving an algorithm per day. Beautiful days at the movies is today's algorithm. Lily likes to play games with integers. She has created a new game where she determines the difference between a number and its reverse. For instance, given the number 12, its reverse is 21. Their difference is 9. The number 120 reversed is 21 and their difference is 99. She decides to apply her game to decision making. She will look at a numbered range of days and will only go to a movie on a beautiful day. Okay, we have a range and the number k. Determine the number of days in the range that are beautiful. Beautiful numbers are defined as numbers where the day minus the reverse of the day is evenly divisible by k. Okay, print the number of, well, printing most of the times is not the case, it's returning the number of beautiful days. Alright, let's get to it then. For sure we want to go from I to j and we want to say day in, so we have the day, and we can say number equals day. So then while number is bigger than 0, because we want to get the digits, we can get the digits with the help of modulo. So we can get, for example, the digit, maybe we should form an array, perhaps. Shall we? Maybe this is the multiplicator. Multiplicator, let's just call it m. And that's 10. Because we want to say, for example, we have the result here, or like the reverse, 0. We can say the number modulo 10, that's the digit. If it's 9 modulo 10, the result will be 9. If it's 10 modulo 10, the result will be 0. If it's 11, it's gonna be 1. If it's 12, it's gonna be 2. So we have that first digit whenever. So then this is the first digit. We can say that multiplied by m is plus, right? We want to say result. Result is equal result plus that. And then we can say number equal, oh, we can do that. Number is equal, oh, can we? No, we should remove that last digit. Wait a second. Oh, yeah. Number is number divided by 10. So then we have that last digit and then plus, for example, for 0, it should be times 0, 10 times 0. For 1, it should be 1. And then we have 0 plus 1, which is 10, which stays. That's interesting. For example, for the number 10, right? How would that look like? We would have the number, it's 10 divisible by 10, that's 0. Multiplied by 10, that's still 0. So 0 plus 0, 10 stays 0. And then you say, okay, we're getting to the digit 1. We're still bigger than 0, so that means 1 divisible by 10 is 1. Multiplied by 10 is 10, so we say 0 plus 10 is 10, which shouldn't be the case. It should be 1, the reverse of it. Okay, I think what we want to do is, when we have the result, we want to basically not say times m on what we got out of as a digit, but whenever we get in here, we basically want to say r is r times m. We want to move it up by 1. Now we got the reverse. Now we can say basically day minus r modulo k equals 0, beautiful day plus 1. And we will have to capture beautiful day 0 up here. Or have at least that if. And then we can say return beautiful day. Let's see if that works. Nope. My output is 0, expected output is 2. So let's see. For 20. For 20, we are having 20. We say basically 0 plus 0 stays 0, and then we get the 2. Then we are in here and we're saying, okay, moving it up, we should have 2, which means then down here, day minus 2 is, so 20 minus 2 is 18 divided by 6, 6, 12, 18 should be 3. So that should actually work. Maybe I should do this. Perhaps that one. Alright, it runs a little bit too long. Let's do this trick down here. Still processing. Oh, there we go. It didn't execute within time limits. Do I have an endless loop? I should not have an endless loop, I would say. Because number is overwritten. We could do like a print here and see print number of get. Oh, now it works. Interesting. And now submit the code. Let's see, it runs a little bit too long. Do we have any errors? Oh yeah, timeout. Still timeout. Even though we're doing basically, I mean, we're still looping like a million times, but damn. That means there must be a way of doing that even. Oh, what if just this print statement, you know, takes up time? I guess the catch here is remove your print statements and then you will execute more likely in time. Perfect. So that worked. That was today's algorithm. Thanks for watching. I hope you enjoyed me cracking that one. And I hope I see you next time. Do not miss out on tomorrow's algorithm. You can subscribe and also like the video if you want to support me. Have a good one. See you then.